On days like this, we can see drag at work on any highway. Eddying air swirling behind the moving vehicles, wasting their horsepower and their fuel by holding them back, producing a chaotic pressure pattern like this. Drag can be measured. Take a disc of given area and put it in the mouth of an open wind tunnel. Mount the disc on a sprung slide attached to the indicator arm of a calibrated gauge. The airspeed in the tunnel is measured by an airspeed indicator. Notice first that as the speed increases, so does the drag. In fact, the drag increases as the square of speed. With the airspeed indicator steady at 100 miles an hour, the drag on the disc records a value of 5 on the gauge. If we mount a disc double the area of the first, the drag gauge records a value of 10 at the same airspeed, double the drag. Finally, if we mount a disc only half the area of the first and a quarter of the area of the second, we get a reading of only 2.5 at the same airspeed. So the amount of drag depends on both the frontal area of the disc and on the speed of the airflow. However, aeroplanes nowadays can present very large frontal areas to the airflow and somehow manage to fly around at over 600 miles an hour. So there must be an answer. And there is. Streamlining. If we add a bullet-shaped nose to the medium-sized disc, the drag reading at 100 miles an hour is reduced from 5 to just over 1. Add a streamlined tail, and it goes down to less than 1. The drag arising from the shape and size of an aeroplane is known as form drag or normal pressure drag. And if the shape is sufficiently streamlined, the size doesn't matter so much. One obvious way of streamlining an aeroplane is to give it retractable landing gear and eliminate struts. The results of cleaning up the form in this way are often worthwhile, both in terms of performance and fuel economy. But if the gear has to be fixed, then the answer is to streamline it along with the rest of the aeroplane.